Okay, so this is the additional review, problem number 11. Solving, this is with a calculator, 5 secant squared minus 19 equals 4. Okay, so first of all, we're just going to solve it. So we'll get secant squared by itself. So it looks like secant squared is 23/5, which means cosine squared is 5/23, which means cosine, be careful, plus or minus the square root of 5/23. Now, because it's plus or minus, that means I'm actually going to have 4 answers, because the cosine is positive in these 2 quadrants and negative in these 2 quadrants. So I'm going to get all 4 answers. Now, I need my reference angle. So this is why I need a calculator. If that had been √3/2, then I wouldn't have needed a calculator. But since it's square root of 5/23, I'm going to second cosine the square root of 5/23, and I got 1.086. How does that sound to anybody who did it? Does that sound right? Okay, so now what are my answers? I have 4 of them, and the first one is 1.086. But now, how will I find the second one? That's the one over here in the second quadrant. That will be pi minus that. So pi minus 1.086, which is 2.056. And then the next one will be pi plus 1.086. $4.228. And the last one will be 2 pi minus 1.086, which is 5.197. Okay, I don't know who asked for that, but does that help?
Yeah.
All right, who else? Alex?
Can you do 13, please?
13. Okay, so remember when we say prove, it's like just like in geometry. We're going to take your given and ultimately transform it into the to prove. Okay? Now I couldn't help but when I was writing this down, something popped into my head. What do you think of? Does anything pop into your head when you have tangent squares and secants in the same problem? Does anything come into your head that you have memorized? Avery?
Tangent squared equals secant squared minus.
Yeah. So we have a Pythagorean identity that says 1 plus tangent squared is secant squared. So when I see that tangent squared on top of secants, I'm thinking, Alex, maybe I'll do what she said. I'll change that tangent squared into secant squared minus 1. Now, nothing cancels at this point, but what can I do with my numerator?
Oh, you can
Factor it. And when I factor it in the difference of squares, then I can cancel that denominator, and I am left with secant minus 1. Now, what is secant? 1 over cosine. So now I have 1 over cosine minus 1. I'm subtracting. What do I need when I subtract with fractions involved? Common denominator. And there it is, Alex. My common denominator is cosine, and I have 1 minus cosine. Now, an alternative, I think that's probably the quickest way to do it, and an alternative, something I want you to always keep in the back of your mind is the building blocks of trigonometry are sine and cosine. So could you change tangent squared into sines and cosines? Yes, sine squared over cosine squared. Secant is 1 over cosine. So you could have taken this and just changed it all into sines and cosines. Keeping in mind that you're ending with cosines, when you change that guy into sine squared over cosine squared, that right there, sine squared is 1 minus cosine squared. So you could have rewritten this whole thing, it would have been big, but in terms of cosines, and then just started peeling it down. That would have been another option. I think this was the fastest, but yeah. Okay, I thought there was one more. Was there one more question somebody had?
Number 9.
Number 9. All right, what's the issue with number 9? You got a 2x in there, and boys and girls, you do not want, 2x's are fine if they're the only thing in the problem. You don't want a 2x and a regular x. So, I don't really have a choice. I'm gonna have to get rid of that 2x. So what do you think? What do you think about that?
1 minus sine squared.
Be careful. Cosine squared is 1 minus sine squared. But this is not cosine squared. This is cosine double x, 2x. You see the difference?
You could do cosine squared minus sine squared.
So this is the identity. Cosine 2x actually has 3 forms. And I know that you have a lot to memorize. So you may not want to memorize all 3 forms. But the 3 forms, you got to know at least one of them. The 3 forms are these. These are all cosine 2x. If you have all 3 memorized, which would be the best option for this particular problem? This one, because it has sines already, right? If you use this one, which is fine, you would need to change your cosine squared into 1 minus sine squared, and same here, right? Because you need sines. So I'm going to use this one. So 1 minus 2 sine squared plus sine x equals 0. Scout, you still with us? Now, what kind of an equation is that? It's quadratic, right? What am I going to do with my quadratic? Well, it's already set equal to 0. Maybe I'll get it in the right order and then factor it. So 1 plus sine minus 2 sine squared equals 0. It's kind of backwards, but I hate those negatives there, so I'm going to write this way. Now I'm going to factor it. I have 1s. Then I have to have a 2 sign somewhere. And now my signs. think that's right. Does that look okay to everybody? So what does it say? Sine x equals 1, or sine x equals -1/2. Now you don't need a calculator for this one, because you know where the sine is 1. Where is the sine 1? At pi over 2. You also know where the sine is -1/2. It's a pi over 6 down below, so it'll be 7 pi over 6 or 11 pi over 6. Did that problem have a domain on it? Yeah, so that's it, we're done. I think there was one like that on the other review sheet. I mean, on the original review sheet. If there's a 2x in the problem, you've got to get rid of it. All right, anybody find anything else as you were working through these?
Can you do number 5?
5 is another solve, and it has a cosine 2x in it. So, looking at the whole problem, the whole rest of the problem, it's a cosine 2x again in problem 5. So I'm going to use one of these. Which one do you think would be the best one this time? This one? Look, the problem's full of cosines. Do you see that? So let's not mix and match. Let's just keep it cosines. So I have cosine squared plus 2 cosine plus 2 equals 2 cosine squared minus 1. If I plug in this formula for my cosine 2x. So let's get this quadratic cleaned up. So I'm gonna have cosine squared minus 2 cosine minus 3. Did I do that right? Now I can factor. So cosine equals -1 or 3. Can cosine equal 3? Extraneous. Throw it out. Where does cosine equal -1? Only one place. Pi. Yep. There you go. All that work for pi.
Could you do 6?
6. We're gonna sketch. So this is all the ones you've done so far have been like equations. This is a graph. So we're sketching. When I write it down, Mary Kate, I'm gonna pull that 1/2 out. Because in order to sketch, I need to have that 1/2 out of the parentheses. So if I divide out a 1/2, that's like multiplying by 2, so this would be pi over 6. And again, I can check that easy enough. So it's 1/2 times 1/6, 1/12, so I'm good. I'm good. Okay, now I'm gonna sketch it. So I got a midline or vertical shift of the, a 1. An amplitude of 4, so 2. So it's gonna be 5, -3. A phase shift of pi over 6. So that means what normally happens with a cosine at 0 now happens at pi over 6. So that's where my curve's going to start, right there. Now I know what shape it's going to have. I'm going to figure out what the period is. So my period is supposed to be 2 pi, but I've divided it by 1/2, so now my period is 4 pi, right? So to keep some kind of reasonable scale, pi is, oops, I erased it. 4 pi is 24/6. So there's 1. Okay, so 2, 3, 4, 5, 6, 7, 8, 9, 10. Can't remember. Yeah, I'm ending at 25/6 because I started at 1. So I know here I'm gonna have that same point. Looks like right there. Now, halfway in between the peaks is the valley. So what's halfway in between 1 and 25? 1 and 25 is 26, divided by 2 is 13. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's my halfway point, and that's gonna be my valley, which is down here at -3. Now, halfway between 1 and 13, which would be 7, 6, 1, 2. Halfway in between is my 0, where I cross the axis. And then similarly, halfway between 13 and 25, which is 19. I cross again. So now I'm going to connect these with some kind of a, hopefully somewhat symmetrical curve, and there it is. Okay. All right, good. Who else?
Number 3.
3?
Yeah.
Find all the asymptotes of -3 cotangent. All right, so first of all, I gotta remember what a cotangent looks like. Just a regular cotangent. As an asymptote, looks like that. That is my regular cotangent, standard old cotangent. When we start putting numbers into the problem, what does a negative do to my picture? Flips it upside down, but it doesn't have anything to do with the asymptotes, right? The negative isn't gonna change the asymptotes. What does that, the guy, do? He stretches it. Is that gonna have anything to do with the asymptotes? No. What does this do? That changes the period, doesn't it? And will changing the period change my asymptotes? Yeah. So in terms of this equation, this is the only thing, that 1/3 right there is the only thing I really need to think about. So what does a 1/3 on the x do to your period?
Makes it bigger.
Multiplies it by 3. Because remember, that's a divider. Just like up here in this one, we took 2 pi and divided it by 1/2. Now we're taking pi and dividing it by 1/3. So this asymptote won't be at pi anymore, it will be at 3 pi. And the next one will be at 6 pi, and so on. So your asymptotes are gonna be 3 pi apart. Now, is the first one still at 0? Yeah, we haven't changed that one. So I would say your asymptotes are going to be at 0 plus or minus multiples of 3 pi, because that's your period now.
Or should that cosine be a cotangent in the middle?
Thank you. Someday you'll be 66.
Give it a hard
I
time.
know.
People watching the video don't want to get confused.
Maybe.
All right, what else? 12? Okay, now 12 is another proof, so it's just like the one we did earlier. Our job is to do something on the left side so that we can ultimately change it into the right side. Okay? So what is that going to look like? Okay, so, nothing here is square, boys and girls. So you're not gonna change cotangent into cosecant. The identity says 1 plus cotangent squared is cosecant squared. If they're not squared, you're not changing them. How can you change cotangent though? Cotangent by definition is what? Well, 1 over tangent, what else is it? Cosine over sine. So I'm gonna change this into cosine over sine, and this into sine over cosine. And Sophia, my thinking is, I need to end up with essentially 1 over cosine and 1 over sine. So I'm gonna get these in sines and cosines, because there's no way to change them to that, so, okay. Now, what do I got? I got a couple of fractions. I'm gonna add them. What do I need in order to add them? Common denominator will be sine cosine. This one needs a cosine. I'm not clearing the fractions. I'm adding them together. So there's my common denominator. This one needs a sine. Oh my goodness. What's my numerator? 1. My numerator's 1. So now I have 1 over sine cosine. Now we don't do this very often, but would you agree that that is the same as 1 over sine times 1 over cosine? Aren't these equal? And that is cosecant and that is secant, which is what we want. Okay, now, if you are thinking, I can never do this on my own, I want you to put those thoughts out of your brain, because you absolutely can do this on your own. Did I do anything fancy in that problem? No. I needed to know that cotangent was cosine over sine and tangent was sine over cosine. But after that, it's just arithmetic. Get a common denominator, right? You can do this. All right, anything else on that page?
Yeah, this isn't like for the page, but are there gonna be a lot of the like proof ones on the AP exam?
No.
Okay.
Well, I mean, I don't know, I didn't write the AP exam based on everything that's
Yeah.
written, no.
Okay.
There's not a lot of anything, because you only have, it's one test,
Yeah.
so. There's a lot, but not any particular thing. All right, anything else there? All right, when I handed all this stuff out, I gave you a thing called magic square. Do you remember that? It's called magic square. Mr. Passwater made this. And it's like a little game thing, and it's fine if you wanna play, do the game thing on your own, that's all right. But it has a lot of good problems on it, so. Looking at the problems on the magic square review paper, called magic square. You need a new organizational system now.
I can throw all the old stuff away.
Don't, you haven't taken an AP exam yet, don't throw anything away.
You're right. I need to store it on
I think you're gonna look back through all that.
And, I think that this experience has been one of the most glorious of your life, and you would not want to throw it away ever because you have.
frame it all.
All right, so, looking at
Pass it
this,
on to the next one.
let's do a problem that we haven't done one in a while, and that would be like number, or letter F. Let's look at letter F. This was 3.1, the very, very first thing in the unit. Take a second, you and your partner, and see if you can remember how to do 3.1, letter F. So we're on the magic review, or magic square review, and we're looking at letter F. Seeing if we remember how to figure it out.
Table above.
The table is above it.
What team are you from?
Shut up and scrub.
Language Terry.
What?
Language Terry.
How do you scrub is not that good.
What did people use yesterday? Dingleberry?
He did well.
Amy didn't know what it was.
I didn't know the exact. Have you ever heard Chicken Dinner Session? Oh, I've heard it 150 times. But
That's it?
understand. I do not have that page.
We didn't letter G, right?
Let me just
What are you doing? Overthinking it?
yeah.
Alright, so, period 8.
Yeah.
You're looking for negative 7.
So
So what I did is I added 8 to negative 7 1.
oh,
So,
forgot about that track.
and then 20.
Yeah, 16.
And now you subtract it, and you get 4. So,
Okay, what does being periodic mean?
multiple of 8.
28.
Periodic means it repeats, right? It
Forgot about
cycles
that,
through.
Rich.
And that, for this thing, if the period's 8, then that means what happens at 1 happens again at 9, right? And again at 17, and so on and so on. So you need to figure out, where does negative 7 fall in all that? What did you decide? 1 minus 8. So you go, whatever's happening at 1 is gonna happen again at negative 7. So f of negative 7 is the same as f of 1, which is 14. Now, what did you decide about 20? It is 16 plus 4. So f of 4 is gonna be the same as f of 20. And that is, f of 4 is a negative 5. So hopefully you got 14 plus negative 5 and you got 9 as your answer. Is that okay with everybody? Remember, whatever the period is, that, you repeat that spacing. So every 8, so start with your number, go forward 8, backward 8. All right, now, Kellen said, since I'm looking at this page, what about G? That looks a little crazy. So take a second look at G and see if you can figure it out, and then we'll talk about it.
I was overthinking it. I think I got it.
I think you got it? All right, well, that's good.
That equation just looks scary.
It does look scary, the problem looks scary. Don't let the problem psych you out, it really isn't that hard.
Are these all no calculus?
Alright, here we go, we gotta evaluate this. What is the angle whose sine is negative root 3 over 2? Now, Gus said, is this no calculator? Yes, it can be no calculator because that's one of my special numbers, right? If that had been, root 13 or something, then I'd have trouble, I'd need a calculator. But this I know. Where is the angle whose sine, this is an angle, where is the angle whose sine is negative root 3 over 2?
4 pi over 3 plus 1 over 2.
Remember, there are rules about this. It's gotta be over here, gotta be over here. Negative would mean it's gotta be down here, right? And since it's gotta be between negative pi over 2 and pi over 2, whatever I say, it's gonna be this negative angle right here. So what size angle has a sine of root 3 over 2? Pi over 3. So what am I gonna say? Not 5 pi over 3. Negative pi over 3. This direction is very specific. This right here is negative pi over 3. If I were solving an equation and the domain was given like this, then I couldn't say negative pi over 3. I would have to say 5 pi over 3. But this says I gotta say negative pi over 3. Okay? And then I gotta multiply it by 3. So negative pi, right? Which is about negative 3.14 or something. So look on your graph. Where is y negative 3.14 on the graph? How many places? It says how many solutions does it have? So how many places is the y value negative 3.14?
4.
Looks like there's 4 of them. Would you agree with me? Draw a little horizontal line where y is negative 3.14. And how many places does that horizontal line cross your curve? I think 4 times, doesn't it? So the answer is 4. How many solutions does it have? Okay. Now I want to look at A. I'm kind of looking through. I just want to make sure A is a very basic problem. But the way that things are worded and all the notation, sometimes it seems a little scary. What are you going to do for problem A? H of pi, what does that mean? What do I do? Plug in pi. Plug in pi. So all you're going to do is 6 minus 5 secant pi over 3. Right? Now, what's the secant of pi over 3? I don't know. What's the cosine of pi over 3?
1 or 1/2.
1/2. So the secant would be 2. Right? If the cosine of pi over 3 is 1/2, the secant will be 2. So this is 6 minus 5 times 2. So the answer is negative 4. Don't make it hard. Guys, do not make it hard. Oh, okay. Let's try B, another one of these table values. Take a minute, what do you think? Can you figure that out? I got an answer. Anybody get one? Anybody have an idea? Alex?
So it's normally when you plug in 0 for x, it normally is at the point 0, 0, but it's, the y is 1 there, so d has to equal 1.
Okay, so he is so very logical. That is absolutely great. If you got lost in that, just take this point and plug it in. So this is y. So 1 equals a tan 0, put 0 in here, plus d. Well, what is the tangent of 0? 0. So this is 0, so d is 1. So now I know that d is 1, so I'm just gonna put 1 there. Okay, now what, Alex?
And then you plug in, the next point.
Now we can do the same thing here. Plug in negative 1 y. And 1/4 for x. What is the tangent of pi over 4? Be careful.
Oh, 1.
It's 1. So negative 1 equals a, because this is 1, plus 1. So it looks like a is negative 2. So here is my equation now. We built the equation because we found d from that point, and we found whatever that was a from that point. Now, we got lucky because when we plugged in that point, we actually got one of our variables. A lot of times what happens is you have to plug in both points and you have a system of equations to solve. We didn't have to do that this time, but that happens a lot. Okay, so now we're gonna plug in 3/4 right here, right here. So we have negative 2 tangent 3/4 pi plus 1. What is the tangent of 3 pi over 4?
That's negative 1.
That one's negative 1. So 2 times negative 1, or negative 2 times negative 1 is 2, plus 1 is 3. So k is 3.
Have that equation, like 2 positive.
Let's go ahead and do C. While we're here, we might as well. From the graph, see if you can find the values of A and B and D so that you can multiply them all together.
Very easy, I like this. variables, A, B, and C.
Multiply the variable, look.
Correct.
Maybe one half, cause I feel
Pi,
like.
okay, 2 pi over x equals the period, period is 4 pi. 2 pi over x equals 4 pi. 4 pi x equals 2 pi.
So we put the period under, put the period for x. So 2 pi over 4 pi. You put 2 pi over the period.
The period equals 2 over b.
Yeah. You put,
The period equals 2 pi over b. We're trying to find b. So it would be 4 pi equals 2 pi.
yeah, B would be right there. B's 1/2.
Find b right now.
B's 1/2.
Huh?
1/2.
You don't have to find a like we did there.
What's 2 pi?
All right, what'd you get for A? Did you find the
I don't know
A?
what you're saying.
Negative 4? How come it's negative?
Negative cosine.
Cosine's upside down, that's right. What did you get for B? 1/2, because if the period's 4 pi, it's supposed to be 2 pi, so we must have divided by 1/2. And then what was your D? 1? So when I multiplied them all together, I got negative 2. Is that what you got?
Yep.
Perfect. D should be a snap. D, tell me what you get. So C gets negative pi over 2.
I should have canceled out the time.
No,
Well, you didn't say it. You didn't say it's a bullshit. You said two weak explanation.
my explanation is not great.
I was just, you were right.
What? Negative 1. Why is it negative 1? Because the sign down there is negative 1, and the reciprocal of negative 1 is negative 1. There you go, perfect. How about E? Boy, that's a scary looking thing, but you should know the answer to that pretty quickly. What does that mess equal? 0. Why does it equal 0?
1 minus 1 is 0. 0 over anything.
Actually, it's not 0. It tricked me too. That's not sine squared plus cosine squared on the top. It's a FOIL. So it's sine squared plus 2 sine cosine plus cosine squared minus 1 over sine cosine. Now, this and this and this make 0. Would you agree with that?
Yeah.
But now we have 2 sine cosine over sine cosine, so it actually equals 2. Because this is gonna cancel, and it equals 2. That caught me too, when I first looked at it. Great minds think alike, absolutely. All right, H, polar coordinates. I don't know how many answers there are. There could be lots of them. I don't know. Negative 2, 3 pi over 4. I only got one match. That was 5. 5, yeah. Did anybody find another one that matches? I think 5 is the same. Because when we change the sign on R, our angle changes by pi. Is that okay with everybody? Just 5? All right, how about I? Find the value of tan tan 5 pi over 4. Last one, let's see if we can get it back. Tan 5 pi over 4. Very good. Only it's positive 1. Why is the tangent of 5 pi over 4 positive 1?
Because it's
Quadrant 3
Because it's in quadrant 3, y over x is gonna be positive, yeah. And then cosecant 7 pi over 6. I think I heard somebody say that the cosecant of 7 pi over 6 is -2. So when I add them, I get -1. Yes, -1. So tomorrow, I see tomorrow. So tomorrow we'll have our unit 3 quiz, and then we will start.
Physics pre-calc.